There we go. So it's a parallel glider. And let's break it into chunks. What does parallel mean? Who remembers what parallel means? Kind of.
I do.
What do you got for me, Trevon?
It means that it'll never cross.
Two lines that run side by side that will never cross. Think about the railroad tracks. Those are two lines that are parallel, right? They will never cross themselves. Those two bars will never cross themselves. If you look at the lines of the ceiling, those are parallel. They will never cross. Now, if you look at your shapes, your square here, this line is parallel to this line, right? That means that they'll never cross. These two lines are parallel. Now, what this parallel glider does, it will glide, if you go back, to where then you can make a parallel line. Did you see how I did that? Now I have a cube instead of a square. All right, there you go, Leo. So you have a cube now instead of a square. I then can erase my orthogonals. Do you see the cube now? So that's what the parallel glider does. You're able to then roll parallel lines. Now I've got the triangle. I roll through my orthogonals. Now I have a what? A pyramid. So now I'm making these simple shapes. I'm giving that illusion of three-dimensionality on a two-dimensional surface. Using those basic principles come up by who? Who came up with those principles? Oh, somebody said it. Burlesky. So now the lightning bolt, I'm rolling that parallel, drawing that there. Now, would I use this? Is this line parallel to this line, the top of the lightning bolt? No. So what I would have to do is adjust. Now I know this line here is parallel to this line here. So I would go to the longer line to make sure it's parallel and then go across, making my lightning bolt. I would do the same here. And the closer you get to the center of the parallel glider, the more accurate you'll be. Sometimes if it's not on your paper though, if you see, it's not on my paper, I went to roll, it sometimes wants to slide. See how I don't have the same texture or the same friction? So make sure, sometimes you have to go back and double check that it's parallel, because now I can erase my orthogonals, and I have, or lighten them at least. Now I've got a lightning bolt, I've got a pyramid, and I've got a cube. All right, now let me put in my orthogonal here for my circle so that I can build that sphere. How many of you are going along with me in doing this? A few of you, good. So now this is a circle, right? Just like this here is a circle. Now, when I do this, it's now a sphere, isn't it? So if the top is a circle, what is the bottom? Huh? A circle. So I'm going, this curve here, I'm going to have the exact same curve here. It's another circle that fits within those orthogonals. Do you see that? So do you see how I'm just drawing a circle there? Now, this is where a lot of artists will use their circle guide. Now here, now you see that I've got a cylinder. Now, did you see when I had that circle in there? Kind of looks like a cup, doesn't it? Now we've got depth within side. So now we've got our rectangle down here. Basically what I would do is line up the parallel glider, boom, straight across. Now I've got a rectangular prism. How many of you are finding this a lot easier now? Is it easier? Now, how many of you had problems with the crescent or the croissant? A couple of you? How many orthogonals were there? Do we all agree? 3? Anybody disagree? There are 3. There's one from each point, right? So let me get all 3 in. One from each point. But it's a circle, right? So we have to go to the outside of that circle with another orthogonal. It's a small one, but it doesn't cross itself, does it? And the reason being is, look at, to do that crescent moon, you need to then have that curve, and then you've got to copy the exact same curve and go to that line. Do you see it? Do you see how now it looks like it's 3-dimensional? The hardest part will be trying to copy this curve. While you're doing that, I will put in the orthogonals for the, as you guys were calling it yesterday, the candy cane. And all of them are going to the vanishing point. Quite. Remember, precision is key. So, what I would do here is use my parallel glider to go up. You can use your ruler too. Just make sure that you're see how I just did the little curve there? I use my parallel glider here to make sure that these lines are parallel. No, sliding. So let me, making sure. And then you follow that curve over. If you've got solid orthogonals and you can make those lines parallel, you're able to make those geometric shapes. Raise your hand if you're getting this. Good. Oh, okay, give me a thumbs up, middle thumb, or thumbs down. Middle thumb, thumbs up, middle thumb. Okay, a lot of middle thumbs. The more you do it, again with anything, the more you do it, repetition, the better you'll be at it, the more you'll get it. Remember, it's a three-step principle. What are the three things that we need to do one-point linear perspective? Who can give me one of them? Chloe. Vanishing point, we've got that. What else? Collab. Orthogonals. Those are the lines, the angled lines that go to our vanishing point. And one last thing. What is the last one? McGuell. Huh? Well, pencil, yes, you should have a pencil. But what are the three principles of one-point linear perspective? We've got orthogonals. We've got vanishing point. Horizon line, which is also known as eye level. You knew it. You second guessed yourself, didn't you? I should have made you answer it. All right. So, these are the orthogonals. All right. There you go, bud. And again, it is just using parallel lines to create that shape. And see where it hits here? That's where I'm going to stop with the parallel glider. Because if I stop here, I know that goes straight across, and now I've got that shape. So it's key that where this line, where I stop here, if I would have stopped here, would those lines match? No. Now the teardrop, did anybody have problems with the teardrop? What I noticed a lot of people did was that. They did the one line. But if there's a top, there's a bottom. And again, this is where you just follow that line. And that's where using that right brain, really looking at it. I'm looking at that line as I'm drawing next to it to make it as parallel as possible to give that shape. Anybody have problems with the star? No one? Let's see if you got all the spots. This is the one that most people miss throughout the day. They eventually found it, but it was that one right there. Huh? You got that one? A lot of people miss that point, that center of the star. And again, I'm taking my time to line that up for precision. Now, why am I not doing this point here? Who knows why I'm not doing that point? Emma? I'll go through the shape. I don't need that point. that shape is going to cover, that three-dimensional shape is going to cover that point, so I don't need to do it. Now, if I was going to like recess this in and make it like a star-shaped box, then I would need that line, okay? And I'll show you with the lightning bolt here in a minute, but let's get this shape. So again, I am going from, now if you look, these lines line up. This line is parallel. This line is parallel. Or I mean, these lines are not parallel, but they're lined up. So I come here. If I want my star to be about that thick, I bring my line here. I bring my line there. Now I rotate my paper. Now I rotate my paper because I know that this continues on. It's an implied line. And I then, nope, it's this one I want to do. And I'm sliding. You can oftentimes feel when the parallel glider slides when you're off your paper and on like a slick surface, one side wants to slide. Have you guys noticed that? Yeah? Notice I'm not going fast, am I? Perspective is precise, it's precision. Making sure those lines line up. Notice again, where this line was, I go to that line because they will meet. Now, if I start to lighten up or remove my orthogonals, I now have a three-dimensional star. I've given the illusion of three-dimensionality on a two-dimensional surface. Now, who can, I'm old and senility starts to set in. Who was the one who codified Brzezinski's discovery? Who was that? Alberti. Alberti codified it. Nice job. He codified it. What does it mean to codify? Kendall. He did what? Ran it down. So like how you'd run down a crook? Just chase after it? What do you mean by run down? Yeah, he simplified it. Codified. Think of it as like a cheat code. He made a cheat code for artists for one-point linear perspective. He took the discovery of Brzezinski, codified it, and then made the first how-to book. All right, so that's all you're doing is going from the points of the shapes to the vanishing point, making sure you get all the orthogonals. Sometimes it doesn't look like you need it. A lot of people didn't do this one here. They're like, well, it would be flat. Well, if it would be flat, it would be on the horizon line. If this line was just like that, it would be down on the horizon line. That means that I can go from my vanishing point to that corner, and I still see the bottom. I don't see much of the bottom, but I still see the bottom. So then I go from the bottom, I rule down, I put my parallel line, because this line is now parallel to that, and that's what gives the illusion of three-dimensionality. And that's all we're doing. And then I roll this over until I see where that line intersects, and then I go up. Now look at, I could have had it here, right? But I went back. See how much more interesting it is when you have overlapping shapes? Doesn't that look a lot more interesting? Yeah, that's how you can use perspective to build your composition. When I say fill your space and make an interesting composition. That's overlapping things. You know, pushing things in the foreground, putting things in the background, the middle ground, overlapping things. You guys came in with such a fear of overlapping. You're going to have to overlap in perspective. All right. What do we have? One more shape to do? Orthogonal. And that's off. As you can see, I'm just not quite right. So let's. How many of you found you were erasing more? Trying to be yeah. With perspective, it's hard to let those things go. And some of you were trying to do it without a ruler yesterday. Were you guys successful? No. And again, if you look, I'm lining it up, and I'm going until those lines meet. That way you're certain to get the exact same size shape. Now, once you get this complete, all you need to do, along with your notes, take a photo of this. Now, take your time and refine it, because I'm grading you on precision. Remember, it needs to be precise. You need to use a straight edge. You don't have to have a parallel glider. You can make it parallel. You're not making that big of a gap that you can't eyeball it. Take a photo, upload it to the assignment. That way it's waiting to be turned in. That way if you lose it, you've got a photo of it, at least. It's already in the hopper. It's in the hopper. It's ready to go up. It's ready to turn in. All right? We just did this in class. Yes? There should be no reason why you don't have it, unless you didn't follow along. I will post this video to the Google, so you have it in case you lose it and you need to repeat it. Any questions? All right.